Hi guys, this is Proshun again. Today we will discuss some theory of the complex number, that is with the I. When we have discussed the first two topics of complex number, at that time we come across I in a multiple situations. I is generally associated with the imaginary part of the complex number, and and we know that I equal to root over minus 1. That's fine, but there are some other properties of I, as well as if we go for I square, I cubed, I to the power 4, that is different powers of I. At that time we will find out what are the relations between them. There is a relation, and that we will find out. And another thing we will discuss today, that is the cube root of unity. What is cube root of unity? What are the relations between them? Basically we will derive some of the formulas, and those formulas will be used for the problems and solutions of West Bengal joint, as well as your standard examinations like 12th examinations or 11th examination. So that is the purpose of the topic. So let's move to the power of I. Just let's go ahead with different powers of I. First, let's start with I to the power 1. I to the power 1 equal to I. We know something to the power 1 equal to something, like 2 to the power 1 equal to 2, 3 to the power 1 equal to 3, 5 to the power 1 equal to 5, 20 to the power 1 equal to 20. So that is a normal scenario, and that is I to the power 1 equal to I. Next one is I square. I square equal to minus 1. Why I square equal to minus 1? Because in the definition of the complex number, when we have deduced the definition of complex number from some quadratic equation, at that time, to represent root over minus 1, we have used I. So if root over minus 1 equal to I, so obviously I square equal to minus 1. I think that's clear. Next one is I cubed. I cubed I can write in a form of I square into I. I square equal to minus 1, so minus 1 into I, that becomes minus I. So I cubed equal to minus I. Next we will go through I to the power 4. I to the power 4 I can write as I square whole square. I square equal to minus 1, so minus 1 whole square, that is equal to 1. So I to the power 1 equal to I square equal to minus 1, I cubed equal to minus I, and I to the power 4 equal to 1. So I minus 1 minus I 1. This is the form for the I to the power 1, 2, 3 and 4. Now we will deduce for I to the power 5, 6, 7 and 8, and then we will see what is the relation between them. Next go to I to the power 5. I to the power 5 I can write as I into I to the power 4. I to the power 4 I have written earlier that I to the power 4 equal to 1. So 1 into I, that is equal to I. So you can see I to the power 1 and I to the power 5 are same. Next we will go to I to the power 6. I to the power 6 equal to I square into I to the power 4. I square equal to minus 1, so minus 1, and I to the power 4 equal to 1. So minus 1 into 1, that is minus 1. I can see again I square and I to the power 6 are same. Next, if I go for I to the power 7, I to the power 7 I can write equal to I to the power 6 into I. I to the power 6 I have deduced as minus 1, so minus 1 into I, that is minus I. Here you can see I cubed and I to the power 7 are same. Both are minus I. Next, let's proceed to I to the power 8. I to the power 8 I can write at I to the power 4 whole square. I to the power 4 equal to 1. I have reduced earlier, so I to the power, so 1 square equal to 1. So this is similar to I to the power 4. So I can see that I to the power 1 becomes I to the equal to I to the power 5, I to the I square equal to I to the power 6, I cubed equal to I to the power 7, and I 4 equal to I to the power 8. So similarly it will go. This is the pattern. After every 4 power, the situations is same. So we can remember in a general form like if I take any integer k, I to the power 4k equal to 1, if k equal to 1, so I to the power 4 into 1, that is I to the power 4. I to the power 4 equal to 1, I know. Next one is I to the power 4k plus 1. 4 into, so I to the power 5, if k equal to 1, then I to the power 5. I to the power 5 I know equal to I. Next one is I to the power 4k plus 2. 4k plus 2 means if k equal to 1, then I to the power 6. I to the power 6 equal to minus 1. And I to the power 4k plus 3, if k equal to 1, then I to the power 4 plus 3, I to the power 7. I to the power 7 equal to minus I. So, next we will discuss about the cube root of unity. So whatever we have discussed about I, that thing will help you to remember in examination, and you can put, like whenever you will see I to the power 7 or whenever you will see I to the power 4, you will directly put the term whatever we have deduced earlier. So that will help you to go to the solutions of the problem whatever will come in the examination. Next one is cube root of unity. In the cube root of unity, you can understand that it is this is a cube root, so there will be 3 roots of unity. Unity means 1. So among the 3 roots, we can see if one cube root of 1 I will do, then one root will be 1 and another 2 root will be some complex number. So let's see. So cube root of 1 I have taken x. So 3 cube roots of unity, which are the first one is real means 1, and the other 2 are conjugate complex number. Why that is conjugate complex number, that we will deduce over here. And as those are conjugate complex numbers, so they are called imaginary cube roots of unity. So for unity there are 3 roots. One is real, that is 1, and other 2 are complex numbers, and they are called imaginary cube roots of unity. Now how to deduce these things? Let us assume that the cube root of 1 is z. So cube root of 1 equal to z. Now we will cubing both sides. So 1 equal to z cubed, or I can write z cubed equal to 1. Now I will put this 1 to the left hand side. So z cubed minus 1 equal to 0. Z cube minus 1 means a cube minus b cube. A is z and b is 1 er whole cube basically. So a cube minus b cube formula I know, a minus b into a square plus ab plus b square. So here I am doing equal to z minus 1 into z square plus z plus 1 equal to 0. If I know the product of two terms are 0, so either of them are 0. So either z minus 1 equal to 0, that is z equal to 1, or z square plus z plus 1 equal to 0. Now if z square plus z plus 1 equal to 0, that is a quadratic equation which is equivalent to ax square plus bx plus c equal to 0, and I know the quadratic equation roots are minus b plus minus root over b square minus 4ac by 2a. So we will get the two roots of z. What are those? Two roots of z are minus 1, because that is b equal to b equal to 1, so minus 1 plus minus root over b square minus 4ac. B square means 1 square minus 4, a into a equal to 1 and c equal to 1. So 1 square minus 4 into 1 divided by 2a. 2 and a is 1. So this is the z. If I further simplify this, so it will be minus 1 plus minus root over minus 3, because 1 minus 4 equal to minus 3 by 2. So if I divide by 2, then minus half plus minus root over minus 1 is I, so I root over 3 by 2. So one root is minus half plus I root over 3 by 2, and another root is minus half minus I root over 3 by 2. So now we have deduced 3 roots. One is z equal to 1, another one is minus half plus I root over 3 by 2, and the third one is minus half minus I root over 3 by 2. 1 is the real number, the other two are conjugate complex number. We can see that here minus half plus I root over 3, and what is the conjugate of this? Minus half minus I root over of 3. So they are known as imaginary cube roots of unity. Now we will deduce some of the properties of cube roots of unity. These properties of cube roots of unity directly may ask in the joint entrance examinations, or sometimes with the problems when we are going for the solutions. At that time in different places we have to put this formula to simplify the equations and to get the required answers. So we will discuss about 8 or 9 properties of the cube roots of unity. Let's go one by one. First property is, among the 3 cube roots of unity, one of the cube root is real, that is 1, that's true, and other 2 are conjugate complex number. So the 3 cube roots of unity are 1, minus half plus I root over 3 by 2, and minus half minus I root over 3 by 2. So this property we have already discussed. Hence we conclude that from the cube roots of unity we get 1 is real and the other 2 are so and so are conjugate complex number. So that's also we have discussed. So property 1 is done. Next we will go to the property 2. What? Square of any one imaginary cube root of unity is equal to the other imaginary cube root of unity. So one imaginary cube root square equal to other imaginary cube root. How? Let's see with the example. Let's say one cube root is minus 1 plus root over 3i by 2. So if I square it, it becomes 1 by 4. And a plus b whole square, that is a square plus 2ab plus b square. So minus 1 whole square plus 2 into minus 1 into I root over 3 and plus I root over 3 whole square. So it becomes 1 by 4 minus 1 square whole square equal to 1 minus 2 root over 3i minus 3. So if I just do 1 minus 3, that is minus 2 minus 2 minus 2 root 3i divided by 4. So it becomes minus 1 minus root 3i divided by 2. So that is the other imaginary cube root. So it is proof that one of the square of the imaginary cube root of unity is another imaginary cube root of unity. So we generally denote the imaginary cube root of unity as omega. So if omega square is one imaginary cube root of unity, then the other would be omega. That is a convention we used to follow everywhere. In every book or every joint entrance or every textbook, we will find that omega is denoted as cube root of unity, imaginary cube root of unity. Property 3. Third property is the product of the two imaginary cube roots is 1, or the product of 3 cube roots of unity is 1, because first cube root of unity is 1, which is real. The other two are imaginary cube root of unity, and we will, if we multiply the two imaginary cube root, if that becomes 1, so 1 multiplied by 1, so the product of 3 cube roots of unity are 1. So let's see how that becomes. Let us assume one imaginary cube root of unity, that is omega, equal to minus 1 plus root over 3i by 2. So another imaginary cube root of unity, that is omega square, equal to minus 1 minus root over 3i by 2, because we know in the earlier property that one imaginary cube root of unity is the square of the other. If we square the one imaginary cube root of unity, then the other imaginary cube root of unity comes. So therefore the product of two imaginary cube root of unity or complex cube root equal to omega into omega square, that is minus 1 plus root over 3i by 2 into minus 1 minus root over 3i by 2. So if I multiply this, omega into omega square means omega cubed, and these portions will come as a square minus b square, because a plus b into a minus b. a is -1, so -1 এর whole square minus √3i whole square divided by 2s square. So 1 minus 3i square by 4, I square equal to -1, so 1 plus 3 divided by 4, 4 by 4 equal to 1. So omega cubed equal to 1. The product of three roots equal to 1 omega and omega square. So 1 into omega square equal to 1 into 1 equal to 1. 1 into omega cubed. This is a printing mistake, so it will be 1 into omega cubed equal to 1 into 1 equal to 1. Next one is property 4. It is a fourth property. In the fourth property, we will see that if omega is a root of the equation z cube minus 1 equal to 0, therefore omega satisfies the equation z cube minus 1 equal to 0. Consequently, omega minus 1 equal to 0 or omega equal to 1. Since omega cubed equal to 1, hence omega to the power n equal to omega to the power m, where m is the least non-negative remainder obtained by dividing n by 3. So this is the property. For another 4 properties, that is property number 5. The sum of the 3 cube roots of unity is 0, that is 1 plus omega square equal to 0. This is very important because we will put these types of expression in many places in the real problems and solutions. Okay, so how to prove these things? Very easy. The sum of the 3 cube roots of unity are, one is 1, another one is first imaginary cube root, that is -1 minus √3i by 2, and other one is another imaginary cube root, that is the conjugate of the first one, that is -1 plus √3i divided by 2. So if I sum these three, 1 plus omega square equal to 1 plus minus half plus I √3 by 2 minus half minus I √3 by 2. So I plus I √3 by 2 minus I √3 by 2 negate, and minus half, that is means -1. So 1 plus -1 equal to 0. So property number 5 is proved, where 1 plus omega square equal to 0. Property number 6. Property number 6 is the reciprocal of each imaginary cube roots of unity is the other. The imaginary cube roots of unity are called omega and omega square. So omega equal to, let's say, -1 plus √3y by 2. So, and we know omega into omega square equal to omega cubed, that is equal to 1. We proved earlier. So omega equal to 1 minus omega square, that is also true, and omega square equal to 1 by omega. Hence we conclude that the reciprocal of each imaginary cube roots of unity is the other. Basically omega into omega square equal to 1. So that thing we are proving over here, nothing else. So property number 6 is almost similar to property number 4. Next one is property number 7. Property 7 is, if omega and omega square are the roots of the equation z square plus z plus 1 equal to 0, then minus omega and minus omega square are the roots of the equation z square minus z plus 1 equal to 0. Which check the sign. One is the z square plus z plus 1 equal to 0. Another one z square minus z plus 1 equal to 0. Property 8, that is the last property. Cube roots of -1 are -1, minus omega, and minus omega square. So these are the 8 properties which you need to know, because you have to put these things in different problems and solutions in your joint entrance or earlier other examinations. So that's all about these lessons. In the next lesson we will go through some of the problems and complex number which has come in different examinations, either in WBG or your text examinations, or in any competitive type of examination. So thank you for watching my video. If you like, you just like it in the YouTube, or subscribe me, so that this tutorial can be reached to the wider audience. And thanks once again. Have a good day. Thank you.